So today we just went over in our Zoom class our Unit 1 final project, but we also want to make sure that you get an opportunity to go through it again through an ed puzzle and answer some questions, because it's important that you understand the expectations that Ms. McGee and I have of your class period. So our Unit 1 final project is a project where you have two different options. The first option is to create a step-by-step guide on how to create a scaled copy of a certain shape. The second option is how to use scale in a scaled drawing. This project is due on Wednesday, September 16th by midnight. So again, you'll have some time today during class to work on it. You can work on it over the weekend or throughout Monday, Tuesday, or Wednesday. The first thing you're going to want to do is to choose your option. Your option should be somewhat challenging or challenging for you. So option 1 is called Scaled Factor Fun. In this option, you'll be first drawing an image and labeling only the horizontal and vertical side lengths in all parts of your drawing. You can choose one of the shapes below that we have selected for you, or come up with your own. But if you come up with your own, it should be at least as complicated as these examples. So you can't just choose a rectangle or a square or a triangle. It has to be kind of a unique shape. After you choose your shape and redraw it and label the sides that you can, you're going to create a scaled copy that is larger than your original drawing. Make sure to show your work and label the side lengths in your new drawing. After that, you're going to create a scaled copy that is smaller than your original drawing. Make sure to show your work and label the side lengths in your new drawing. In addition to showing your work mathematically, you're also going to need to write at least 7 sentences to explain your original shape, the scale factors you have chosen, and the larger and smaller copies that you have created. If you're looking for a bonus, go ahead and challenge yourself to find the area of each of the shapes you have drawn. The second option is to scale your dream room. This would be you creating a scaled drawing of your ideal dream room. Your room should contain at least 1 door and 3 pieces of furniture, maybe a desk, your bed, or something else. Then you're going to go ahead and choose one of the scales given below or create your own. Make sure it's reasonable. You have the option of choosing 1 unit to 0.5 feet, or 1 unit to 0.2 meters, or 1 unit to 23 centimeters. Then state the actual size of the item in your room. You get to choose how big these items are, but you should be realistic. Be creative, add color, and have fun. In addition to showing your steps mathematically, please write down at least 7 sentences to explain your room, scale you've chosen, and the actual dimensions. If you need an example, go back to practice day 2 on Desmos to see a scaled room. Don't use this exact room, but you can use it as a model. And again, the bonus for this option is to add more than 3 pieces of furniture to your room and find those dimensions. The second thing after choosing which option you're going to want to do is that you want to choose how to create your project. So you can choose to create your project in your graph notebook that you should have gotten when you picked up your materials. So it should look like this, or maybe you have some other graph paper laying around where you live, or if you have access to printing it out, you could also do that. You could also, so if you choose that option, make sure to attach a picture to this Google Doc, or if you're not sure how to do that, you're going to email or text a picture of your project to your teacher. If you'd like to create your project in Google Slides, you can go to Google Slides and create a presentation. Don't forget to share your slides with your teacher when you're done or while you're working through it, or attach your slides when they're finished to this Google Doc or the assignment. Make sure to keep scrolling for the rubric. So again, keep scrolling until you get to the very end. The third thing you're going to want to also look over before you start your project is the rubric. Make sure that you understand the rubric so that you're not losing points for silly mistakes. You're going to first want to delete this line here, and you're going to type in your name, right? So I would delete it and I would write Ms. Thatcher if this was my document. This project is worth 16 points, and each category that we're grading is out of 4. So the first category that we're looking for is commitment to quality. Your project should be neat and well organized. It should be seen that you produced professional work as a student. And we also want to make sure that the option chosen is a stretch for the student, or if it wasn't a stretch, that you did the bonus to challenge yourself a bit more. If you're doing anything less than that, then you may get a 3 or a 2 or a 1. So I would give yourself a chance to look over what is expected or what these other numbers might mean. The next category that we're looking at is mathematical relevancy. So if you're looking to get a 4, it means that it's obvious which option the student has chosen. So it's clear which option you have picked for this project. It also is clear that the project shows the mathematical concepts. So you're understanding the math concepts and showing that clearly. Also, by reading this project, one has a better understanding of the math concept. So think of your project as kind of a teaching tool that you're trying to teach me how to either scale a drawing or how to use a scale factor in drawing a scaled drawing. Then we're looking for technical writing tools as well. So technical writing tools are things like color coding or using color, using spacing to make it look organized, using diagrams or arrows, headings, examples, labels, and clear organization. So we're really looking for your project to really stand on its own through all of these different writing tools. Again, if you're looking for a 4, you need to use 3 or more of these technical writing tools. Again, you can see what a 3 means, what a 2 means, and what a 1 means. And the last thing we're looking at is sentence total. So again, you should have a written explanation alongside your mathematical explanation. If your written explanation has a minimum of 7 sentences, you will get a 4 in this category. If you have between 5 and 6 sentences, a 3. Between 4 and 5 sentences, a 2, and anything less than 4 sentences will earn a 1 point. So altogether, again, you have a total of 16 points. Again, please make sure that you're familiar with this rubric so that your grade is not a surprise at the end. Hope you have a better understanding of the project, and I hope you all enjoy creating your project. We can't wait to see them.